Welcome back to our next unit in algebra. So we are now in unit number 5, radicals. All right, so our goal for today being day 1, given a radical number, you will be able to simplify it using perfect squares. So let's go ahead, let's flip over and let's talk first about, well, what exactly is a radical? What does it look like? Well, a radical is a square root when it's not a perfect square underneath. So whenever you see this square root, another name for that is a radical. Now, the number on the outside of a radical, this is called your coefficient. Just like the number in front of your variable is the coefficient. Now, the number underneath the square root symbol or the radical, this is called your radicand. Your radicand. So it's the radicand, whatever is underneath that radical symbol. And remember, radical is just a square root. Okay, so part of our goal today was that we are going to simplify our radicals using perfect squares. So let's take a little reminder about what our perfect squares are. So our perfect squares are the numbers that you get when you square our whole numbers. So if we take a look here, well, first off, we should put 1 here. 1 squared is 1. However, we're not typically going to use 1 when simplifying. Our next number, 2 squared. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. So these numbers that we just wrote down, these are our perfect squares. So I'm going to go ahead and put a box around these. These are your perfect squares. Okay, so what makes them so perfect? Well, they're perfect because you can take the square root of them, like the square root of 4 or radical 4, and you get a whole number. If I were to take the square root of 8, or not 8, 8's not a perfect square. If I take the square root of 49, I would get 7. If I take the square root of 64, we would get 8. So these are all of our perfect squares because you can take the square root and you get a perfect number. Now, if you're ever questioning whether or not something is a perfect square, you can always check it in the calculator. So if you look at our square root symbol is above the squared, so we hit second square root, and then I can type in, for instance, 49. I hit enter, and I get a whole number. Now, if it were not a perfect square, for instance, if I put 51 in the calculator and I hit enter, I get my irrational solution there. So 51 is not a perfect square. All right, so we're going to use this idea of perfect squares to help us simplify our radicals. And here are your steps for simplifying. Number 1, we're going to try to square root our number in the calculator. If it works out to a whole number, we know our answer is a perfect square and you're done. If not, we're going to follow through these steps right here. So let's go over to this example here, and we can use that to help us out. So first, we're going to type it in the calculator to see if it works. So the square root of 50. So if I type in the square root of 50 and we hit enter, it's an irrational number. It goes all the way across and it will keep going on forever. So that means it's not a perfect square. So what we're going to do is we're going to find the largest perfect square that will divide evenly into the number under the radical. So my number under the radicand is 50. So here are all my perfect squares. So we need to think which of these numbers will divide evenly into 50. Well, that is going to be 25 and 2. So radical 25 times radical 2 is radical 50. But then if I were to take the square root of 25, I get a perfect integer of 5. So this 25 then comes down into 5. And what we're going to do now is we're going to multiply everything together. So 3 times 5 is 15, and the radical 2 just follows down. Okay, let's try this with a few other examples. Okay, so step number 1, try to see if it works. So the square root of 81, I hit enter, and it works out perfectly. So this whole thing is just equal to 9. It is a perfect square, so you are done. Okay, now if I take a look at the next one, 4 radical 20. Now if I type in the square root of 20, it's an irrational number, so it's not a perfect square, so now I have to follow through my steps. Okay, so we need to find two numbers that multiply to 20, and one of them has to be a perfect square. So let's take a look. So 20, so let's see, smaller than 20 would be 16. So let's see, 20 divided by 16. Nope, doesn't work. So we go to the next one. 20 divided by 9. Nope, it doesn't work. So then 20 divided by 4, we get 5. So 4 times 5 would give me 20. So I'm going to break this down into radical 4 times radical 5, and everything's being multiplied. And then the whole number 4 just stays on the outside. So now we have to go ahead and take our square root. So 4 is going to stay a 4. But then this square root of 4, well, that's a perfect square, so I'm going to cross that out. The square root of 4 is 2, and I'm going to bring that to the outside. So then 2 times 4, and then we get radical 5. So that's going to give us 8 radical 5. And with that, we are done. Okay, let's take a look at the next one, 5 radical 64. So the first thing we have to do is check it in the calculator. The square root of 64, we hit enter, and we get a whole number 8. So 64 is a perfect square, so we don't have to really do much here, because this 5 is going to stay a 5, times the 64 becomes 8. So the square root of 64 is 8, and then we multiply these together to get 40. And we've got our final answer. If I ever wanted to check it in the calculator, I could just type in the original. So 5 radical 64, enter, and we get 40. So I see that it actually matches, and we got it correct. Okay, let's try a couple more where they're not going to be perfect squares. So let's flip it over, and let's take a look here at number 3. So I'm going to put my perfect squares there. So the first thing we want to do is check to see the square root of 18. Nope, it's not a perfect square. So I have to find a whole number that one of my perfect squares that divides evenly into 18. So the square root times square root. So let's take a look. So 18 divided by 16, not going to work. 18 divided by 9, that works. We get 2. So it's going to be radical 9, radical 2, and then negative 3 is in the front, and everything is being multiplied. Now the negative 3 stays the same. Now what is the square root of 9? The square root of 9 is 3. So if I were to do that in calculator, the square root of 9 is 3. And then radical 2 is not a perfect square. If I were to type in the square root of 2, it's an irrational number, so it stays the same. And then I just multiply the coefficients together. So negative 3 times negative 3 is negative 9 radical 2. And that's our final answer. Okay, let's try now number 5. So we have 5 radical 200. So if I check the square root of 200, it is not a perfect square. So now we need to find one of these numbers that will go into 200 evenly. Well, let's take a look. Will 100 go into 200? It sure will. So we're going to break this down into radical 100 times radical 2. And then the 5 stays on the outside, and everything is being multiplied. Okay, so my 5 stays the same. Now what is the square root of 100? The square root of 100 is 10. Can we take the square root of 2? Nope, so it stays square root of 2. And then we multiply the coefficients together. 5 times 10 is 50 radical 2. Okay, let's take a look now at number 6. Now number 6, is this a monomial or a binomial? You got it. It is a binomial because we have one term and then we have the second term. Now radicals are, you can only combine them if you have like terms. So since this 8 does not have a radical with it, it is going to stay separate from the 4 radical 90. So we're going to focus our attention right now on this 4 radical 90, and we're going to try to simplify that. So if I take the square root of 90 and I plug it in, it is irrational. It goes on forever and never repeats. So it's not a perfect square. So I'm going to try to break it down. So which of these numbers will go into 90 evenly? Well, Doesn't divide in 81, nope. 64, 49, nope. 36, nope. 25, nope. 16, let's take a look. 90 divided by 16, nope. How about 90 divided by 9? You got it, it would be 10. So this is going to be 4 times radical 10 times radical 9. Okay, now 4 stays the same. I can't take the square root of 10, so it stays radical 10. And the square root of 9 is 3. Now I'm going to multiply the whole numbers together. So 4 times 3 is going to give me 12 radical 10. Now this 8 is going to come straight down, and then I'm going to subtract them. And that is our final answer there. You cannot combine a radical with a whole number. Okay, let's go ahead now and let's try number 7. Okay, so number 7 we have radical 48. It is not a perfect square, it's irrational. So now we need to find a perfect square that goes into it evenly. So let's take a look here. Well, let's see. So 48, so 36 is smaller than 48. So 48 divided by 36? Nope. 48 divided by 25? Nope. 48 divided by, the next one is 16? Yep, 16 is going to work. So we're going to break this into radical 3 times radical 16. It doesn't matter the order that you put those, because all we're going to be doing is simplifying everything. So the 2 stays the same. Radical 3 stays the same. It's not a perfect square, but 16 is a perfect square. The square root of 16 is 4. And now we can multiply the whole number. So 2 times 4 is 8, radical 3. And we're done. All right, let's go ahead and take a look now at number 8. So we have the square root of 100. If I check that in the calculator, it is 10. So I can just cross it off, and the answer is 10. It is a perfect square. Okay, I'd like you now to try number 9 on your own. I know when you plug it in the computer, there's no radical symbol, so just like write the whole number and then write the word radical and then put in what comes underneath the radical symbol. All right, let's see. Were you able to break it down into radical 25 and radical 2 to get -5 radical 2? Then you've got it. All right, we're going to go down. We're going to skip number 10. What I'd like you to do next is I would like you to try number 11 on your own. Remember to find the biggest perfect square that goes into 72. So go ahead, try it out, and put it in the computer. All right, let's see how you did. Did you break it down into 36 times 2? If you did, then you get 6 times 6 radical 2 and 36 radical 2. All right, last problem of the day. I'd like everybody to try question number 12. All right, let's see. Did you break it down into 9 times 11? And then the square root of 9 is 3 radical 11. All right, ladies and gentlemen, I know today is the first day of radicals. It's a little bit of a harder concept to really understand, so come tomorrow with questions and we'll practice in class. Nice job, everyone.